Sure. Well, that should be the PID right there. Okay.
Okay, we're live.
There's a link to the slides right there, so you guys can pull them down and click on all the links versus type them in. So that's all the first about 4 slides are. It's just links. What time is it?
Oh, it's 5:31.
5:31.
We're 1 minute over.
Start.
Okay, everybody. Welcome to DefSec. As usual, at the same time. If you want a link to the slides, it's right there. link.defsec.club/9-17. They're also linked in Slack, I'm pretty sure, right now. Please do attendance so we know that you're here, and then next time you can get the V app pushed to you. But do it every day or every time we have a meeting so we can keep track of that. It's important. Got that, okay. Cyber Conquest signups. If you haven't signed up yet, please go do it.
That's happening this weekend.
This Sunday. And it's at a later time, so even if you're hungover from Saturday night homecoming, if homecoming's still a thing, you can still make it a DefSec on Sunday. So please sign up. I think we've got like 4 teams right now, or how many teams?
We've got 7.
Oh, dude, it's gonna be a fun event.
I'd still love to see a couple more. We got 40 people signed up to
Even
go.
some math faculty may be participating.
That is
yeah.
amusing.
That's awesome.
There may be a team.
That's awesome. If you don't remember, if you're on a beginner team or even intermediate team, I suppose, we'll help you out a little bit. Like we'll have some DefSec folks walking around to give you hints.
At least.
If you've never done this before, OffSec people help you with the hacking side, deal some damage. We're gonna maybe do some advanced sessions at some point for those of you who think a lot of the stuff we're doing here is remedial or very basic.
Yeah.
Existing members. I don't know.
For everyone who's been here, last year, that's when to sign up so we can get some of those advanced sessions going.
I suppose even if you're still first-time person, you could probably go to it if you can keep up.
If you have the foundation already set up, feel free to sign up or just punch your time in there. That's all that is. It's just for timing information, so I can decide when to do that. We might keep it a little bit even more informal, less lectures, more discussions, and just
doing stuff together,
Yeah,
learning as we go.
Trying to figure stuff out as a group.
So today's lecture presentation, I don't want to call it a lecture because it's interactive more than a lecture. Are we talking about networking? Show of hands, how many of you are first-year students?
Okay.
Handful. Okay, how many of you first-year students have networking experience?
Okay.
1, 2, 3, 4. Okay,
Going up and down.
that's good. So I guess most of you, I don't know what you guys did in high school in terms of like classes you took. It was relating to networking. What was like your technology class in high school you got to use? Some of you want to answer.
It's just us.
FRC.
Okay.
What is it?
FRC.
I don't know what it stands for.
What is FRC?
First Robotics.
Oh,
Okay.
That's kind of cool. I didn't know that.
You did programming for that then, or? Okay. Gotcha.
So I was in high school. We didn't have networking club or DefSec or anything like that. We had like, here's Word and like getting certified doing PowerPoint stuff, like Office certification. And we had like maybe video production for like the news, like the school news. But other than that, we didn't have like technology-based stuff. So like my networking basis was I learned at home, and then when I learned at DSU, taking my networking classes. How many people have taken Networking 101 already? Or I think it's CSC 2.
I would just honestly go all the way back down and do who here doesn't know what an IP address is.
Networking 1, Networking 2. Who's taking Networking 1? Raise a hand.
Okay.
Okay. Networking 2.
Who hasn't taken either of those courses? Okay.
Cool.
Out of that set of people, do you guys, who does not, and don't, it's not something to be ashamed of, who does not know what an IP address is? Okay, that's good. What would help?
If you don't want to answer, honestly, like in person, if you go to questions@defsec.club, you can ask a question anonymously. I'm monitoring on my second screen right here.
For anything during the
Please.
entire night, feel free to go there. Feel free to ask questions. If you don't feel like raising your hand, that's perfect. Okay.
So now we got that out of the way.
Well, there's your first slide done.
You got the V app. Go pull that down
Yep.
if you don't already have it.
Yeah, your people are bad.
Okay, so someone asked, what's an IP address
We'll,
already?
we'll go
That's
through
this
that
next
briefly.
slide.
I'm just trying to figure stuff out.
We get on the VF
Hold down
side.
that VF if you do not have it already, or power it on if you do have it. So right click and just power it on. If you have any trouble with that, there's a couple people in the room who will help you out with that. Yeah.
Someone's got a VPN on.
So proud of you people.
Please
Proxying
stop.
your traffic outside. You're all terrible. Okay, so no, we're just gonna
So,
jump right into the
what
presentation.
is an IP address? Pretty sure most of you probably heard the term IP address, probably. IP stands for Internet Protocol. It is the protocol stack that is for talking over the internet and local network traffic as well. Basic IP-based networking and packet switching was first developed by the Department of Defense back in 70s, maybe 80s, when it was ARPANET and all that. And then it became mainstream for everyone to use these protocols since it was easy and interconnected. But an IP address is just a unique identifying address, I guess, for your machine that's movable, right? You could assign someone an IP address, or they can self-assign someone an IP address. But it is an address that we can use to talk between one another, and we know who we are then. Like I said, you can either dynamically assign one, or you can self-assign one. Has anyone ever heard of DHCP before?
Once again, who has not heard of DHCP?
Yeah, who hasn't then?
No one ever asks. No one ever raises their hand for the inverse questions. Thank you.
I mean, be honest, right? Like, no one's
Yeah,
judging.
yeah. Well, I mean, like we're just trying to figure out what to talk about. So I mean, if you know everything, that's fine. We'll continue to talk
So-
about things you don't know. Hopefully.
Every device that's on a local network and connected to the internet has an IP address. This laptop has an IP address. I think the projectors technically have IP addresses here. It's unique to this local network, and they have to receive it somehow, right? It's got to be set for that device. In the case of my laptop, I use DHCP because DSU has a DHCP server on campus, dynamic host.
Dynamic host configuration
Configuration
protocol
protocol,
is my
yeah.
guess. I don't remember.
So DHCP server hands out and serves IP addresses to devices on the network, so they have it. My laptop has one. Sometimes if you do not have DHCP or you want to set one statically for yourself so you pick it yourself, you could self-assign one as well. And I think we might show that in Windows and Linux tonight as well on those two boxes, how to assign one. But just understand, for competitions and defensive things, devices have an IP address that you can use on the network. When you look at an IP address, in this case 192.168.1.34, you might not know what these numbers actually correspond to or what they mean. Essentially with, I guess actually before, with IP addresses, it reverts back to binary, right? Machines work in binary, and it's an easy way to utilize this. So we've got 4 octets here. And these octets here can, in binary, correspond to what we can maximum put for numbers here. These are the IP addresses. We've got 2 things that make up an IP address, network ID and the host ID. Network ID identifies the network it's on. The host ID is for each individual host. So if you go on, in this case, 192.168.1, that's the network we're on, and each host is whatever's after that, so .34, .1, .5. In the case of DSU is like a slant 16. We won't get too much into slants, but just understand that's the amount of IP addresses you can assign out to someone. At DSU, you'll see every DSU device is always 138.247. Is that what it is at DSU? Yeah, 138.247.0.0. So those last 2 octets are utilized for hosts and other devices that are on the network.
Because we're a /16 network here at DSU, we give everyone a Class B address. So if you actually... see, I swear it switches focus on me. So if you guys look here, down here on my wireless interface, everyone here gets a Class B address, a 138.247 address. That is a public address on the internet. They're all firewalled, so you can't do anything, but those are not NATed. They are not translated. That is an address on the internet that you can theoretically try to navigate to. You won't be able to do anything with it because it's firewalled off, but it's there.
You can actually, you want to hop to the VF real quick and just show the slant 24 IP, because that's all slant 24 right there.
Yeah, then that's a slant 16 right there. And
In most competition environments, you won't be dealing with a lot of large subnets or large networks in terms of that, it's mostly going to be a slant 24 you have given to you.
And for the VApp credentials, DSU or root will work. Password wouldn't bang.
I might have to zoom in a little bit.
Oh, fantastic.
Did you have zoom like this?
I should have Zoom. Yep, there we go. I don't have your fancy Mac Zoom, if that's what you're referring to. Okay. Yeah, so there we just have you should have a private IP address right down here.
Can you guys read that in the back? If not, we can try and zoom it in some more and make it.
I can make an attempt. I think one more will start doing some funky things, but sure.
Maybe highlight over it.
There we are. Yep, that's fine. Maybe try one more. Okay,
Okay, yeah, that's about it.
that's your maxed out.
So notice on this Linux VM in the VApp, right, it has an assigned IP address of 192.168.1.10. It says slant 24. So when you have the slant, it can tell you what the subnet mask is and what type of network you're on.
So the first 3 octets are going to be 192.168.1 is for the network, and that .10 is for the host.
I guess the thing to understand here on Linux, most of the time to check the IP address, where you do IP space A or
Yeah.
IP config.
Yeah, so it's going to be ifconfig is the other one. ifconfig or IP A or IP adder or whatever is they're just alias to each other. IP adder is the other way to do it. Between those two, that's going to cover about nearly all Linux and Unix systems as IPA and ifconfig. Unfortunately, in Linux, we did switch it at some point. IPA is the new standard. ifconfig is the old standard.
So you've got an IP address. It's assigned to an interface, a network interface. In this case, it's ETH0, as you can see here.
Yeah, it's funny. You can't get the mouse on the VM because it eats it.
Okay. So ETH0 is the interface that has this IP address. Typically, every interface has one IP address. Every interface also has one MAC address. We'll talk about MAC addresses in another slide. But just understand that. And then for Linux, IP adder, IP config. You want to go to Windows real quick? We can show that.
Sure, we can show that as well.
On the Windows side, you're probably going to be more familiar with this, since I'm pretty sure most people here had Windows in high school, maybe. Maybe not a
I'm sure
Mac.
there's one kid out there who's just had Linux his entire life.
Probably not.
There has to be at least one, right? It's okay, guys. Windows will load eventually. Okay. We're gonna wait for this one.
While that's loading, question. How many of you are the networking person at your house? Your parents are like, oh, the Wi-Fi's down. I need to fix this, or I can't get the internet. Okay. So in a lot of cases, you probably have a slant 24 at your house internally, right? Like it's usually 192.168.0 dot whatever, or dot 1 dot whatever, maybe a 10 dot something.
One day, I will have. One day, Windows will load. One day. It's probably my fault. I only give it 2 cores. Okay. One day, Windows with its beautiful GUIs will give me an option to do
you're good
things.
now.
Oh no, it's not. There we go. It finally loaded.
So in Windows, to get to
Sure.
check the IP address, you probably just open up command prompt.
I know. I'm trying very hard, believe it or not. Okay, guys. When that text loads in, we'll know.
Okay.
That's about what I expected. Oh yeah, it's going. It's chugging, man. Oh, we crashed Explorer. Just remember, guys, Windows is a superior operating system. I gave it 2 cores. I probably should have given it
How
more.
much RAM?
4 gigs. I'm gonna be honest. I'm actually now questioning the amount of gigs of RAM I gave it.
You gave it 4.
I will be perfectly honest. I gave it 4.
That's like the minimum to run Windows.
I feel justified. You know,
We just
4
had the
gigs should be
question,
enough.
Can't find the DefSec VApp in the catalog. Has it been uploaded? Yes.
You don't want to.
Are
Nick, you want to double check that?
It definitely is. I pulled it down earlier today. But make sure you're in, you go to flash.devsec.com.
Yeah, it's not in
Make sure
projects.
Projects are learned.
We can probably show that in a second. But.
Yeah, we can show that in a second. There we go.
So easy way to check what the IP address is on a Windows system is open up command prompt, CMD, and type ipconfig.
I'm just appreciating Windows right now. I'm just.
Can we zoom in on that a little bit? I don't know if you can change the
Oh, because I have to fix it internally then.
No, I figured can't you just maybe I don't know.
Yes, we can do this. This is fine. I will do this for you.
Cool. So notice here, right? We're 192.168.1.20. We also have the subnet mask there available to us, so we can figure out what slant we're on. Also shows another thing: the default gateway. Does anyone not know what a default gateway is? Which is fine. It's cool. So default gateway, that's the IP address of the router you're going to send your traffic to reach out to the internet. So if you're going to go to Google, it's going to send it to, in this case, 192.168.1.1, which is your router, and your router is going to send it off to the internet. So default gateway is the closest, or at least assigned router for you for that device. And you can change that too if you want to have two routers on a local network. You could, but in this case, there's one.
It is the spot that traffic will always be sent to if your device does not have any alternate route. It's the fallback route.
So actually, we can probably trace.
Oh gosh, yeah, we can do that. Do you remember? Well,
Do you want tracer T?
Remind what the route. Do you remember what the routing table is? Command in Linux.
This is Windows.
Whatever I said. Oh, there's things.
Okay, we don't want to see the routing table. Just
Oh, okay, fine. Yeah. Trace. What do you want? Trace route.
Google 8.8.8.
Yeah.
Tracer T.
You're right. It is tracer T. Guys, I don't use Windows very often.
So tracer T or tracer is just a tool to route where you're touching on the internet to reach your destination. So in this case, our first hop was 192.168.1.1. Our default router or default gateway, it's going to hit that. This is every IP layer device that we're going through to reach our destination. So in this case, we're going through 172.10.10, all those other ones. All the way up to 192, those are actually private IP addresses using NAT. We're going to explain NAT in a slide, but just like that. And then we hit DSU's part, which is 138.247. Request time dot. That typically happens actually. Not all IP devices on the internet will respond back with this information.
Or we just don't have internet.
Did you log in?
We should be good. Nick, do we have internet? Have we checked?
Yeah, I did check that earlier.
Okay.
You want to check? Can you check right now? Just see. Well, if the PFSense box might have timed out. If we're off. Just saying. Yeah, we might have lost auth.
That's okay. Anyways, tracer T, traceroute will point back and show you where you're actually going on the internet to reach your destination, like we said.
Do you want me to show where each of those hops is at? Or not?
Let me try turning it off. How do I manually pull down the VApp? Do you want to show that real quick?
Yeah, I can do that.
So you go to
Oh no, I should probably use the dreaded.
h5.defsec.club.
Yeah, HTML5 or h5.defsec.club will work. Oh no. Hopefully you shouldn't have this. No, I guess they'll have that. DefSec default 2 is where you want to be at for the moment. Gosh, actually no, it's not even that. It's going to be libraries. Yep. So right here, go to libraries. It should take you right into here, and let's see here if I can. Yep. So this one right here. If you start searching DefSec Networking 101, it should be right here. And then did they rename it? Yeah, they just renamed it. So just go here, so click on the little three dots right there, go to create VApp, and then, punch whatever you want in for it. Okay, so apparently this is showing up as 2. It's going to be DefSec default 2. Don't worry about that. That's what it needs to be on for the moment. That'll get deleted eventually when I have time to fix that. Come on. Just next. Next.
I'm guessing you showed
Ready to
clicking
complete.
it from the catalog and everything. You showed selecting it from the catalog.
Oh yeah. And it should. Is it not going to finish out for me? HTML5, please. There's no reason why you need to be mean to me. I did nothing wrong to you.
Jeez.
It's not going to finish. Great.
That's okay, but I mean, they just
That
clicked
should be the process. If it doesn't, I can try it quick.
Whoever's the one still having issues,
Just having
is
Nick
it good
help
now?
you or
Or
something.
you want to put it in the questions? We're good.
Should be off now.
Should be off.
Okay.
So PFSense is fixed now, so we can try tracer T again. It should go all the way back up.
But whoever had the VApp issue, good.
You can also try it
No,
here.
7 issue, yeah.
Okay.
Look at that. You got it?
Yeah, one of you guys.
Um,
I can also try it from here. HTML5 apparently is pretty funny tonight. I don't know why. This is once again, a good reason to tell you. Oh, come on.
good reason to.
There, okay, that solves the problem right there.
Anyways, if you do the attendance at DefSec, we'll automatically push the VAPs
I
out
do
to
it
you.
for you, and I'll deploy out and I fail, and then I work on that for a half an hour, and then I make them work. So that's how that goes.
Okay. Going back to that Windows side, we'll show you traceroute working in.
One more time, yeah.
What is it within that? Cancel.
Yep, as soon as I get started. There we are.
So notice our destination here is Google, which is 8.8.8. That's their IP address, which is kind of cool. They have they own that IP. But traceroute is a tool to show where you're hopping around on your network to actually it gives you visibility, if anything, of where your network's at and what you're doing. But while that loads,
I'm actually wondering what's the still point at this point.
the IA Lab NAT. I'll let you know. We're actually already through.
Yeah,
it.
we're already passed. So this one right here is your pfSense router. That's in your VApp, the one that enabled pfSense. That's that one.
That default gateway.
Yep. And then your pfSense router connects to DefSec 03, and then this is the router on DefSec 03 that I set up, and then this is one of the routers for the IA Lab for vCloud Internet. Actually, is what that one's for. So we basically have a system where we're just traversing up routers until we eventually get to where we want to get to.
I can think we can skip this for now.
I think we will. I don't know why Windows is not behaving well.
So, recap. Every device has some sort of network interface if it's on the internet. Every network interface has an IP address. Default gateway is the route where you're going to send your traffic to if you're trying to go to the internet. IP address corresponds to a subnet mask as well. Subnet mask is used so you can help identify what the network ID is and what the host ID is. If you're just given an IP address that's 192.168.1.34, you can't just assume that the network ID is 192.168.1 and the host ID is 34. You need some way to figure that out. So every interface that gets an IP address on the internet or on a network also gets a corresponding subnet mask, and that tells you what type of network you're on. Right, in this case, we're on a slant 24, or the subnet mask for slant 24 is 255.255.255.0. So that corresponds, so it knows, hey, I know this last octet is the host ID, and these other ones are network ID. So keep that in mind. When you're setting up a system, or when you're looking at an existing system, keep in mind the IP address and the subnet mask so you know that. So now we understand IP addresses, at least partially. Has anyone heard of ports when we're talking about services that's being ran on the internet? Who hasn't heard of network ports or service ports?
Let's just skip it.
How many of you aren't answering? Oh, that's fine. I'm just going to assume you don't.
Oh, yeah, you gotta refresh this too, guys. Just kill that.
So a port on the network, in terms of IP addresses, corresponds to a service. So when you go to a website, let's say dsu.edu, and you type in the name, if you just went to the IP address of it, or the domain name you go to, the URL, it actually has to correspond to a port as well that's running on a system. So when you go to dsu.edu, it's actually port 443. That is a port known for web traffic. There's actually a chart guide all over the internet telling you what each port number corresponds to what type of service. So when someone talks about secure HTTP or web traffic, that's 443. Insecure regular HTTP is typically 80. The rules are not hard set. You could technically put any service you want over a port, but you really want to make sure your service is running on the proper port. And understanding ports is important when we're talking about firewalls later on and securing devices. If you have a machine that runs services, right, you have one IP address, but you have multiple ports or for multiple services off that one IP address on the system. So think of it like you have one connection to something, but you have multiple lines on that connection. It's for each type of port you have for each service. So you can have a computer run multiple services as long as it's not it's not multiple of the same service running on that same port. So you could have two web servers running on one computer if you really wanted to. One running on port 80, one running on port 443.
One running on port 22 doesn't matter. These are the common designations for what it should be, but you're not required by any means. You can have a web server running on any port number from. Can you actually have something on port 0? Does anybody remember? I don't remember.
I don't.
Can I do it on port 0? Can I do it on port 1? Yes. There's no reason I can't do there. So you can have it from 1 to, what, 65535, yeah.
So has everyone got kind of an understanding of ports a little bit?
Think of them as a slot that
Yeah.
that you have a service hosted behind and you can shove stuff into. And they are allocated for whatever that is.
When someone says, I got an FTP server running, you go to the FTP server's IP. The application will actually go to it usually for you, but that's usually colon, 21? Port 21 is running on there. Yeah, for FTP. SSH is port 22 typically. So, actually, how many of you are in 150 right now? Raise your hand.
Okay.
How many are you taking 150 with Tom Helverson?
Lost one.
Do you guys connect to DS Unix with like PuTTY? So when you go to PuTTY, do you remember you go to DS Unix as like the host name and then port 22, right, for the service? You're SSHing into the server so you can run your code and stuff on there. So that's a good way to think about that as well.
Yeah.
So anyone got kind of an understanding of ports around? Who doesn't? Anyone got any questions about ports so far? We're here to answer questions so we understand this.
Feel free to use the application if you don't.
I see nothing in the teacher question, DefSec questions. Moving on, public versus private IP addresses. When you're at home, we talked, typically your IP address is like 192.168.1 dot something or 0 dot something. That's an internal private IP address. IP addresses that are private are the ones below 10.0.0, 172.16.0.0, and 192.168.0.0. These will not route on the internet anywhere. So if you have a device plugged right into the internet somehow that says its IP address is 192.168 dot something, it will not route that. Whatever receiving router gets that traffic will just dump it. It can't. It's built into the protocol, into the spec to do that. It's only internal. Now, if you have a router set up to do private IP addressing internally, sure, it'll route it. But when you see an IP address like that, just understand you have a private IP. Public IPs are anywhere from 254 all the way on within the octets. But does anyone know what you use when you have private IP addresses at home and you want to get to your one public IP address and get out to the internet? Yep, NAT, which is our, well, actually, here's an example of a private network at home, maybe. This one says NAT server. That's usually your home router is running NAT on there. But notice how their network only has one IP address, one public one. Goes out the internet and they have all these private ones inside of it. So NAT. NAT is network address translation. Essentially, you go from a public IP address to a private and vice versa. There needs to be some sort of system in the middle of it that keeps track of what each IP address corresponds to what. So when we're corresponding from a public to a private and a private to a public, there's different versions we can have of translation. You can have one-to-one, which is known as static or destination NAT. One-to-one is we have one public IP address for one private IP address, no matter what. So if you have 5 IP addresses at home somehow, typically you have 256 actually, if you're a slant 24. Those correspond to each their own public IP address as well. Then there's one many, or known as PAT or source NAT. That is, we have one public IP address to multiple private IP addresses. And that's what you typically have at home. Your ISP or internet service provider at home is not going to give you 255, 256 public IP addresses so you can have them at home. They're going to give you one public IP address to go to your router. Your router is going to have a NAT service running on there, and NAT's going to convert that one public IP address to multiple private IP addresses and keep track of the connections in between. So that's important to understand. If you're doing firewalling or anything else, you need to know the source and destination IP addresses when you're making these firewall rules and changes. So you have to keep track of that, and certain firewalls do it a certain way. Do you put the NATed address or the pre or post NATed address, the public address? So it's something to keep in mind. You might have also heard this at home. Maybe you running something at home and you want to make it so it's publicly available. You got to port forward. Your one public IP address needs to correspond to a service that's on a private IP address. So typically, you have a web server running at home on your home computer, 192.168.1.4. That's running on port 80. You need to port forward that so any traffic going to your public IP address that's on your router on 80 will automatically go to 192.168.1.4. But you can only have one then because you only have one public IP address, and only one address has one of every single port available. So keep that in mind as well. Any questions about NAT? Might have went a little fast there, but we can explain it. NAT's definitely an important topic if you get into a competition where NAT is set up.
Most of the internet currently runs on NAT when you get down to it.
Yep. NAT is, we only have a certain amount of IPv4 addresses. It's like a couple million or something like that, maybe. There's a lot more people than that. Maybe more than a million. I don't know. I don't keep track. How much?
4.2 billion.
Billion?
Sounds about right.
Okay. Well, we have more devices than that, I'm pretty sure, at this point in the world. Shit, we have stuff in space with IP addresses. So, what are you supposed to do if you have all these, you don't have enough public IP addresses? You just assign people one private one and subnet it out with private IP addresses, so we have that. It's a lot cheaper just to give everyone one public IP address at home and then use NAT to give it to other people within it.
Yep. The core concept of NAT is that we just keep rewriting the IP address portion when we're sending out packets. We just change the IP, either the source IP or the destination IP, depending on what we're doing.
So here's a good example of one-to-one NAT. Can you read that in the back, those IP addresses?
Stupid tiny. No. Oh, thanks, Google Slides. That's 300% zoom, guys. Okay, wow,
Yeah,
that disappoints me in general, but I don't think I can fix it, unfortunately, at the
That's
moment.
fine. I'm pretty sure they can read it back there. So here's a one-to-one NAT example. Here's your private network. You're going 192.168.1.0/24, so that's all 255 addresses that are in there. One-to-one NAT to 22.33.44.0. So in that case, in the table to the right with one-to-one NAT, 192.168.1.1 internally NATed IP corresponds to 22.33.44.1 and vice versa all the way down. That's one-to-one NAT. The only time you'll probably ever use one-to-one NAT in a competition is if you're setting up NAT yourself or they have that set up for you already.
Yeah.
NAT actually can be used partially as a security obfuscation tool in some cases. If they don't know the actual internal IP address, that might help, I guess, where they don't know your whole network actually. But it's,
You'll be given one-to-one NAT for a lot of these competitions, by the way, actually. Because the cool thing about one-to-one NAT is that that's the simplest way to map one external address to one internal.
we don't have that in CCDC.
Don't we? Oh, no, not for nationals, we didn't. Well, you'll get that for
We didn't have it
semi-conquest.
for, oh, okay.
Yeah.
Well, I don't remember how Ice Age and, what's the other one?
Argon.
Argon CDC or whatever, how that is.
And Cyberforce. but yeah.
Cyberforce, sorry. But that's one-to-one NAT. You have so many public IP addresses going to the same amount of internal private IP addresses. One-to-many, like we said, is like the typical home setup. You have one public IP address available to you. In this case, it's 22.33.44.55, and that's corresponding to multiple private ones in there. In this case, we show how the ports, you have to port forward them and show them. So you only have one public one, but you have multiple ports corresponding to multiple internal IPs. And there's also the many NAT. That one is just we have so many public IP addresses and a different number of private IP addresses to correspond them to. That one you have to customize and actually select which ones you want. You probably won't be doing that too much, that's for sure, I don't think. Any questions about the NAT examples? Everyone got somewhat of an understanding of one-to-one NAT and one-to-many NAT? Many public to the same amount of private, or one public to many private? Cool. MAC addresses. Besides a public or besides a private or an IP address assigned to your network interface, you typically also have a MAC address. Has anyone not heard of a MAC address before? It's okay if you haven't. Just okay. MAC address is media access control. This is actually an address that's assigned to the network interface from the factory. So you don't actually set one yourself. When you have a device come, your device will have a MAC address usually listed like somewhere on the device electronically, also physically, typically a sticker or engraved. But you have a MAC address. MAC address is this physical address that's really tied to hardware, really. Yeah.
Supposed to be
We're not going to
tied
talk about
hardware.
spoofing, I don't think.
Oh,
but
well, why not?
I guess we can't. You could spoof a MAC address if you really wanted to. You can edit it depending on the operating system in there and say, hey, actually my MAC address is different. But the theory behind it is you have one unique IP, or one unique MAC address for every single device in the world. but we mainly use MAC addresses for local traffic, not from router to router, from inside on a switch. So does anyone not know the difference between a switch and a router? Right, you have a network switch, multiple ports typically. You talk locally on that. To go outbound to the internet or to another network, you have a router that sends it to. The router goes out. When we're talking about switching on a local network, if I'm plugged into DSU and you're plugged into typically the same building, we're going to be on the same switch. We're plugged in. We actually utilize MAC addresses to talk. So if you want to talk to, say, your machine A is at 192.168.1.5, and you want to talk to machine B, which is 192.168.1.10, you know we're locally together. To do it, machine A needs to figure out how to talk to you. When you're switching or sending traffic on a local network, you actually don't send it directly to that IP address. You send it to their MAC address. And in order to find the MAC address, there's a few ways to figure it out. You either already had it looked up before and you have it in your table on your machine. So machine A has what we call an ARP table. The ARP table should keep track of what IP address corresponds to what MAC address on the network. If it doesn't, it utilizes the tool ARP, or Address Resolution Protocol, to actually figure out what MAC address comes from the IP address. So machine A looks up, doesn't have it in its ARP table, so it actually goes, ARPs, and asks, hey, what's the MAC address for 192.168.1.10? It'll ARP, that broadcasts out on the network. Your device, the machine B will respond back to it saying, hey, I'm 192.168.1.10, here's my MAC address, now you can talk to me. And I'll actually craft a packet to send out onto the network with it. So a good way to look at that is when you have a packet on the network, which holds your data, forward and receive destination, IP addresses, there's MAC address before it as well when you have an Ethernet frame. So in this case, machine A will put its MAC address in the sender spot here, and it'll put machine B's now known MAC address into the receiver spot. I know there's a lot in there, but just understand when we're switching or on a local network, we use MAC addresses for sending frames within that as an IP packet where the actual IP address is. It's important to understand because switching tables and ARP tables are important if you're in a competition where you have your IPs already set and the MAC addresses are already there. If someone wants to get onto your network and say that, hey, I'm actually 192.168.1.10, how are they going to do that? Well, they're going to broadcast out saying, actually, my MAC address for 192.168.1.10 is this MAC address now. And now everyone's going to update their ARP table on the network. And when it wants to send a packet, it's going to look at its ARP table or ARP out. And it's going to see, oh, actually, machine C, this MAC address, corresponds to 192.168.1.10, which is bad if you're always communicating from one server to another server and someone spoofs that. Now they're getting all your traffic. If it's not encrypted or if you don't want that person to get that traffic, they could take all the traffic, take down a service, and that's not good, right? And security-wise, they're getting all your network traffic. This is a real-world experience. We had this at National CCDC this year, where someone got onto the network, spoofed the IP or the MAC address and IP address of a phone, and was able to use that to laterally move within the network.
Actually, no, they stole the IP address of the phone and they MAC'd our gateway.
MAC'd our gateway.
Yes.
So that when anyone was sending traffic to the gateway to reach out to the internet, it was really going to their VM that they had on the network to steal all this traffic. They stole all of our traffic we were going out to the internet.
Which they weren't doing it to steal our traffic. They were doing it because if you send all that traffic through a particular point, they then
stop it.
Well, they slowed it down. They basically DOSed the entire network by taking all the traffic from the network and throwing it through a choke. What they actually was they increased the frame size of the packets to something stupidly large, so it slowed down the entire network. So they had a fun time with that at Nationals.
You guys probably could have drawn a diagram of like someone spoofing a MAC address or spoofing an IP address with ARP. But everyone kind of understand how that works. Machines A, machine B have MAC addresses, IP addresses. Machine C can somehow get in there, spoof, and it'll get all the traffic from in between. Everyone cool on switching then? Not seeing any questions in the online part either. So after switching, when we're going from router to router or going out to the internet, we're going to actually do routing. Routing is actually IP base. We strip that whole frame and we just keep the IP packet part. So before you had this whole frame and packet here, it has the MAC address part up here. We strip that off, and now we're left with the bottom two parts, which is the IP packet and the other data within it. So now all we're dealing with is IP addresses. There's no MAC addresses really. So when a router or a firewall is dealing with packets, it's doing it IP-based completely. And when we're talking traffic between them, they usually have a routing table or a way to look up and see how to route the traffic with the protocol. I don't think we have to get too much into that for this case. We don't want to steal too much thunder from the Networking 101 class where you actually learn a lot more of this.
Tell us.
With Tullis, actually, Shinji now teaches that as
is
well. There's actually a few people teaching Network 101 now. Networking 101 and 102 are probably classes a lot of people take. At least Networking 101 everyone takes if you're in the Beacom College. Computer science, NetSec, CyberOps. I guess game design probably doesn't now that I think about it. But everyone takes Networking 1 just like everyone takes CSC 150 or 105 at least. Actually, you take both. But networking makes the world go around in terms of that. So we just talked about routers. They do IP addresses and doing traffic. What's a firewall then? Does anyone actually want to say what the difference between a router and a firewall is? Someone who hasn't talked maybe or wants to talk.
Normally, you're going to have multiple different devices bundled into your home device. But any distinctions?
Come on, guys, let's get the conversation going.
Oh, there's a Kyle in there in the corner.
Okay, Kyle, what do you guys say, Kyle? What's the difference?
Router is just like full send. I see traffic that wants to go here, so be free. And firewall actually has like some amount of control, and it's like, hey, this doesn't match one of my rules. I don't want you to come into the network. Or, oh yeah, sure, enter.
Yep. So firewall is just a router with advanced routing capabilities and filtering and restrictions. It has a rule set, right? You create firewall rules, and when it routes, it checks those firewall rules before it tries to route that traffic. So you could have a rule in there that says traffic from machine A to machine B, if this is going between a router or firewall and the network, do not allow traffic or do not allow web traffic. Keep that in mind, right, for firewalls. It allows you to restrict network traffic between in and out of a network. There's typically two different modes when you have a firewall. You have layer 3 and layer 2 mode. We're going to talk about layers in another slide, but layer 3 mode is just we're dealing with IP addresses only, and that one you have to deal with actual routing with the firewall. So it actually has default gateways built into it, routes, nets built in there maybe to some degree. The layer 2 mode, that's just acting like a switch that does firewall rules on top of switching. It doesn't do any routing. It doesn't really care about IP addresses too much in terms I need to know where to send it. It does it like it's a switch. It just looks for MAC addresses and pulls it up. Layer 2 firewalls are a lot easier to integrate into an existing environment. You don't have to worry about IP addressing or schemes with that. It just will pick up from the ARP tables and load itself. But you get that filtering, that advanced capability a regular firewall does in a layer 2 device. You can filter based on IP address, source, and destination. You can filter based on services or ports that they're using. You can filter based on traffic or data within it, application transport and presentation data layer. Anything that's in that payload here, we can, in theory, filter based on that depending on the capabilities of the firewall and if it's not encrypted.
Most your dumb firewalls are mostly going to focus on your source and destination port and your source and destination IP address, and then when we get into Palos, we get into deep packet inspection that can play with the application layer data.
So one of the beautiful things and the beauty of DefSec is we're going to have more and more hands-on labs where we actually set up a firewall and set up rules within it, set up intrusion prevention systems and other network access devices and stuff like that to actually perform security with. So I know we're talking more theory right now, maybe showing off a few things, but there's going to be a time where you have a VApp and you're actually going to have your own firewall and you're going to start restricting things between devices. Actually, I guess we could probably show that here. We have a pfSense, but...
Yeah, we have a pfSense, but we won't be going over
Yeah.
host-based firewalls next week.
When you get into... The biggest thing with DefSec is to prepare you for competitions, right? These cyber defense competitions. One of the first things you're going to have like a check sheet, right? You're going to get in there and be like, I need the first thing you do is change the passwords on this device. Second thing is maybe I need to put the firewall up locally and network firewall. I need to set these firewall rules to be like, okay, this is a database server. I need to make sure I'm blocking all traffic besides database traffic in or traffic to access a database, let's say, or that service. So understanding IP addresses, understanding NAT, understanding ports and services, understanding firewalls is extremely important. Even if you're not the networking person on a cybersecurity team, local devices have their own firewalls sometimes as well. Actually, most of the time they do. Windows has a local firewall. Linux, you can use IP tables as a local firewall. Mac has their own version of a firewall running on there. It's important. It's definitely a strong tool to have. You'll find many businesses do not do local firewall rules. That's kind of a shame. Local firewall rules extremely cut back on the attack vector of that device. Does anyone got any questions about firewalls? Any cool things they want to mention or things they've seen in the wild
Just
about
anything
it?
at all.
Yeah. Interaction, come on.
I know of universities that have done a bad job with their natting and their firewalling, so they expose a lot of clients to the internet. I remember we got that a couple of years ago. We had that fun realization that a South Dakota university had exposed quite a bit of their systems just open to the internet.
Jeez. So we talked about different network layers here, right? Layer 2 versus layer 3. Someone just asked, doesn't Windows have their own firewall built in?
Yes.
I did mention that, yes. Windows has their own. I guess we could probably show it real quick.
It's gonna
Windows 10.
It's gonna be a minute if we do that.
Is Windows
It's sufficient enough to say that it does have its own firewall built in. We'll be going over those more in depth next week. They're host-based firewalls. They are for that specific device. Like my laptop right here has IP tables running on it right now as its firewall. And then there's also your network-based firewall. So yes, Windows does have its own firewall, and we'll be going into depth next week anyway.
Okay, we are. Oh, we're doing Windows firewall.
Yes, next week is Windows firewall. That's
Next
why
week,
I'd
Windows
wait.
firewall, and we'll show you how to secure down a Windows device with the firewall. So network layers. We talked a little bit about network layers. This is one of the first things you're going to learn if you take networking 101 or networking 1, wherever we call it here at DSU. That there's different layers within this traffic, this packet we're sending on the internet. Layer 1, right down here, is the physical layer. This is you're plugged in with an Ethernet or Ethernet wire. You're plugged in with a coax. You're wireless. You're on light fiber. Like that's that physical link you're connected onto. Then there's layer 2, which is the link layer. That's the MAC address. That's that local switching layer. Everyone's on the same network ID, on the IP address. Everyone's on that same local network. They're going to use the MAC address and the link layer there to switch. That does switching there. Layer 3 is the network layer. That's IP addresses. I guess a good thing to stand out. We've been talking about IPv4 addresses this whole time. I don't know if we're going to get into IPv6 addresses later on. Maybe IPsec, maybe an advanced session. Majority of the time, I don't think I've ever gotten to a competition where we've had IPv6.
It's not even major networking. I mean, it's out there, but it's a lot more rare.
IPv6 has not been prevalently adopted in the U.S. because the U.S. is very stubborn, actually. Europe, it's highly adopted, actually, a lot more than the U.S. Because U.S. we like a good old IPv4, and we don't change for anyone, even those damn Europeans, I guess. But yes, things take longer maybe to change in the U.S., but we use IPv4. It's easier. There's 4 octets. All you got to remember is that IPv6, it gets more complicated in terms of how you do IP addressing, but just keep that in mind. And then above from there are the other layers. Transport layer, you might have heard TCP versus UDP. Or I don't know if we should get into that, really. Just understand, the biggest layers for you to understand the competition, in my opinion, are layers 1 through 3, and then probably layer 7, which is application layer. If you have a firewall, you want to filter based on services or filter based on what type of application is running in that data payload there within a packet or a frame. You have to know what application it is. So if you want to filter and say, I want no FTP traffic going to my router, because that may be a vulnerability that's running over that or something, make a firewall rule. Right? Your rule is deny from anything to my router this specific application, FTP, or this port, 21. But understand that layer is there. It also corresponds to the TCP/IP model as well. And that's just application versus transport, internet, and network access. They kind of combine things. This is more granular and easy for me to remember, actually. But you got anything to add to that, Cutshaw?
Nope.
Oh, good old DNS. Who doesn't know what DNS is? It's okay if you don't. Yeah. DNS, domain name service. DNS allows us as humans to have something we can remember to correspond to an IP address. So when you go to dsu.edu, that actually has to be looked up on DNS to find the IP address, because the internet talks IP addresses. We don't really route with URLs or domain names. We actually have to convert that to the IP address. So your computer, you tell it to go to dsu.edu, it figures out what the IP address of dsu.edu is, and it sends it off to there, and actually asks for the web page. We can actually show that. You want to pull up your, at least locally, I guess?
I'll just put up a terminal. Yeah.
So, actually, if you go to IP config, show actually show in there your network setting. So typically, right, we said a computer has IP address, MAC address. If you look under IP add or IP config or IF config, there's also other information there, including your DNS server you have set up. So when you want to go to a website, your local machine keeps track of DNS entries to know what URL or domain goes to what IP address. If it doesn't know it, it needs to go somewhere and ask for it. Typically, when you're on a local network, you also have a DNS server running somewhere. At home, your router typically runs DNS for you already and keeps track of that. So your computer's like, I don't know what dsu.edu corresponds to, so it has to go look up on its DNS server and ask, hey, DNS server, do you know what dsu.edu corresponds to what IP address? It queries it, it responds back, hey, client, this is the IP address for dsu.edu, have fun. We're actually showing that here a little bit, right? It's asking the DNS server, hey, what's the IP address of abcd.com? It responds, hey, there it is. And then your computer goes out, requests that website at that IP address. One thing to remember there is your local DNS server needs to pull its DNS entries from somewhere else as well. A hierarchy DNS server or whichever one it sets it to. In competition environment, there's a good chance you're going to be running your own local DNS server. Typically, Windows Domain Controller runs it, or you might have a Linux one. But remember that's all your DNS entries for your network to use. You can alter them in there. If someone controls that and you're using DNS for services and host time or hosted services or things that are being scored on a cybersecurity network for competition, and it's DNS based, they get control of your DNS server. That could really screw things up there. DNS really does help run the world, at least in human readable format. You control someone's DNS server, you can control where they go. If I look up what dsu.edu corresponds to IP address wise, the DNS server here is compromised. It could tell me to go to facebook.com or something like that, or give it the IP address or the IP address of their own local server that's making it look like dsu.edu and try and harvest your data or use that to steal other things. So DNS is important. We'll actually show here, there's a tool in Linux and Windows called NSLookup. This is a tool that queries your server so you can look up yourself instead of the web browser doing it to figure out what IP address corresponds to what website. So in this case, right, we asked the DNS server, hey, what's defsec.club's IP address? It says 167.71.168.168. That's kind of cool.
I don't know how you got that one.
But it actually found the public IP address for it. So if we really want to, do you want to try going to that IP address?
We will see what defenses Cody has on that and whether he has Cloudflare set up, because Cloudflare will shut us down. He does not. Thanks, Cody.
So,
Just remember, guy. So Cody has multiple websites hosted on that one IP address, and because we didn't go to defsec.club, it redirected us to his website instead of defsec.club's website.
What port does he use?
What?
What port does
It
he
is not the port, it's virtual hosting.
Oh,
It's
is it
based on the
the
URL.
virtual-
It grabs the
geez.
URL and determines, but because we shoved in the IP address, it went to the default one.
We'll have to have a day talking about using Apache redirect.
Yeah,
or
but
something
we'll
like that.
we'll get into that later about virtual hosting, being able to host multiple websites, multiple domain names on a
We
single
can probably
website.
try.
I am amused by that.
You want to go to terminal again? I don't know how you use your stupid Linux.
I don't know how.
Do
That's the one.
dsu.edu real quick.
Sure.
So dsu.edu responds back with what 138.247. You want to go to that real quick? DSU response 13247. What is that? 117.12. You want to go to that? In the
I will
browser?
go to that and see what happens. Yes, I'm perfectly content. Yeah, we're good.
So it's automatically redirected to DSU.edu, but understand DSU.edu in theory is being hosted at that one IP address. How do you make a DNS server? You could code one, I guess, yourself from scratch. That is a lot of work, network programming and socket programming. But you can host your own, really, if you wanted to, at home. Typically, your home router already has one built in. Actually, before it goes out,
So
it checks your local host.
It's a DNS forwarder.
You can put DNS entries locally
I
if you
guess.
wanted
I guess
to.
it's technically. Okay.
For competition-wise,
depends.
you're going to have your own one hosted. Maybe you might have an inject saying, hey, host your own now. With Windows, if you're in a Windows server environment, you have a Windows domain controller, which we're going over, I think, when we go over more Windows.
Yep.
Did you go over Windows domain controllers at Windows Basic? Who
No.
taught that? That was Nick, right?
We'll get there. We'll get there. Might be a couple sessions.
You
down
taught
the road.
Windows Basic, right, last week?
Yeah, but they
Did you
didn't-
go over
didn't
domain
DNS
controllers?
now. No, it's just
Okay.
basic stuff. Yeah.
So domain controller on a Windows environment's hosted. That typically runs a DNS server as well, so it can correspond the local names to addresses. But
So if you want to build your own DNS server, you're either going to do it on Windows, and then it's going to be Windows Server 2016. And I think you can literally just add the role for the DNS server, and then you have it, and you just need to configure it. Or Linux, you're going to be using either like Bind9, which you're going to install and then configure, or DNS Mask. You're going to install.
DNS
and
Mask is pretty
configure.
popular.
Yeah, it's super light. DNS Mask is super lightweight. Bind is your more fully featured DNS server. So you can host one yourself. There's no
Did that
issue with
answer that person's question, whoever that was?
I could show you how to do it right now, but we'd be here for another hour.
So, I guess that's a do it. Someone said do it now.
Sure, stay after.
A little summary of, I guess, what we've gone over so far, right? Every device or every network interface on a device has an IP address, a MAC address. The device also has to have its DNS server known, or that as well. Its default gateway needs to be known so it can route traffic out. MAC addresses are how devices talk to each other on a local data or layer 2 link. Please. Someone is very determined on here for us to set up a DNS server up here. So IP addresses are used for getting IP addresses used to get the MAC address for local network. IP addresses used for routing when we're going between routers and going out to the internet. NATing or ports. When we're talking about ports or services, you have many ports on one IP address. Those ports correspond to a service typically. We have NAT. NAT allows you to go from public to private IP address. Also with port forwarding. Typically competitions are set up in probably private IP environments. I don't think I've been in one where it's like you actually have a public IP address that's like 222.5 dot something, or 138.247 in DSU's case.
They're all troll answers at this point.
I want to know whose IP address is 24.9.78.212.
That's an interesting one because they're either on the web or they proxied themselves. So
It's me. Yes, I know it's you. Your IP address is here. I see the log. So you've got NAT, you've got ports. Competitions typically are private IPs. I've seen IP addresses in like the 10.0.0 range. That's actually most competitions I've seen. I don't know what you've got more experience than me. I've had only CCDC really.
it's sure, I guess it's whatever. It's
Nick,
just
got any input there?
it's just an IP address.
Cyber Force and ISH are all over the place.
Are they? Damn DOE, whatever they do with it. So besides that, you've got firewalls as well. Firewalls are going to be an important part of DefSec, important part of you securing down a local box, securing a network, and securing an environment in general. Understanding how a firewall works and the capabilities you can do with it is very important. Is there anything else?
Yeah.
Any other questions? Things we just gone over that you want more clarification on, or we can, talk a little differently about it. Anything we didn't talk about you want to know about? We can talk about it
Any
now.
more advanced topics, any more protocol stuff, anything you'd like to know in depth is open if you would like to do it right now. Okay. If not, I think we'll close the meeting for the night then. Nick, got anything else to add before we close up? Cyber Conquest signups are still out there. Please go and sign up for that. That will be this weekend, 22nd. What time we starting?
2 o'clock.
starting at 2 o'clock and going to 5. It will be a fun competition. Please, make an attempt to show up. If it's beginner, it'll be very intro level. You guys will just be facing off against each other, and it is a lot of fun.
I guess we can show this too if you want to show.
Sure.
Another website for you to remember if you want. DSUcomputer.club is now a website. It's being hosted that just shows what's going on this week. Yeah, did you? Yeah. What's the link to get to that thing he was making, that calendar?
Oh, Chris's?
Go to events.dsu Computer Club.
DSUcomputer.club.
Oh my gosh, we're stealing all of the club domains.
It's awesome. I like it a lot.
Bailey, please. Okay.
So this is even cooler. Put an event in there.
I like how this is wrong. Oh no. Oh no, what is this even?
No, it's not like finalized yet.
Oh.
Yeah, because we're not doing a mock.
This
we're
is-
doing cool.
Okay, so there's nothing correct up here yet. Okay. I just had to verify.
That's awesome.
So this is a site, everything on here is wrong.
But it's going to be updated.
But it will be right. Okay, yeah. Give them some time to
But
set
the
it.
other, just DSUcomputer.club is updated. It looks like fully.
Yep. And
And I'll try and update that every week.
one day, Bailey, we'll
Two of
get
our national
legitimate
CCDC
CSS.
participants.
I know, you gotta, yeah. We both went to nationals, so it was fun.
Yes.
Go to OffSec to
OffSec is
figure out how to hack
tomorrow.
things.
We've got DefSec next week as well. Sign up for Cyber Conquest. That's this Sunday. I don't know what the cutoff date is to sign up. Do we have a...
The cutoff date is, are you there at given time? As a reminder, you must pay dues to go to Cyber Conquest or any other computer club, defense and security club, programming club, any of our events. You must pay dues to do that. We will check at some point, and we will say no at some point.
Well, yeah.
Yes.
Please pay. We'll be collecting it
$10.
today. Right now, we've got computer club people here. We'll collect at Cyber Conquest if you're going to compete that day and haven't paid yet. Pay that day. Yep. Any
That's-
questions? Anything?
Yeah. If you want to stay after and talk about stuff, that's cool too. Oh, and the advanced sessions are there. I know for your returners, this is really fundamental stuff. So if you want to start doing some more advanced stuff, please do that when to meet so I can get a good time of when we want to slot that.
Someone asked what that when to meet is for.
So what we do here as part of DefSec, this is normally on a year basis, we're going to start at the very beginning and then we're going to go all the way through. That way we can get everybody up on the same level. Everybody has a chance to get the same knowledge versus, just continually doing advanced topics into the sun. So what we do is we start at the bottom, we go up. Advanced is more for those people who have already been here a year, who know these kind of topics, maybe from some other place. That's where we're going to do either more advanced lectures where we're going to be talking about setting up more complicated services, or just general discussion stuff, lab stuff about anything else. It's for more advanced people who already have some of the fundamentals down. And I'm just trying to figure out a good date to schedule that because obviously there's a lot going on during the week, and I don't want to schedule over the top of your guys' stuff, so people can actually show up. That's all that's for. I think that's about it, though. So in that case, I think we're going to close.
How do we pay dues? Just come to one of
Give
the
us
computer club
money.
people. It's $10 cash. I think we don't have the card reader right now, do we?
No, we do not.
We should just set up some online site where you put your credit card in and pay. Well, I know that sounds
That is
sketchy, but
fantastic.
use like PayPal or something.
I'll host the site.
Can I just give you my credit card right now?
Yeah, that'd be great.
I'm sure we can do some.
But one of us, we can collect money.
Yeah, just do it up here. I have to pay dues too. I have to get Bailey money. Or my.
Try and get a card reader at Cyber Conquest as well for people.
Oh, true.
We should do that because there will be some.
Yeah, if you haven't paid and you're competing in the competition, you can't compete without paying.
Yeah, no, we're not going to let you compete if you don't pay
Just
at least
give
that
us-
day or
yeah.
beforehand.
It's gonna be the best, cheapest investment you'll ever make.
Honestly, for $10, you're getting a nice environment to play with, and you're getting multiple events to
Think
compete
about
in.
spending $10 to get like thousands of dollars.
I mean, in theory, you're not supposed to be in here right now if you didn't pay. So
We
you're getting some knowledge. You
we
pay
do
a couple
meetings.
$1,000 for this class, I guess, if you're going to pay
Well,
the
that's
DSU.
true.
But
We're a 3 credit
Better
course, guys.
quality too.
Well, the thing is, if you go to like CCDC, then that's a lot of money.
Yeah, the cost to send, like, put on events,
Yes.
like programming competitions, internal competitions, sending someone to a competition, that costs money. And paying your fees really helps with that a lot because we don't get as much money from the university as you would think.
They don't pay me.
We're working on getting some external corporate sponsors.
Yeah, and we'll see how it goes. But dues are important. Dues is a computer club requirement, so we're doing it. Okay, so if we don't need to cover anything else, I'm gonna close out for the night, guys. Have a nice day.
Will they have card readers tomorrow? Probably not, unless right. Okay, currently not planned to have a card reader tomorrow. Bring cash. There's an ATM on campus. It's over in the TC. Aw, darn. Okay, that's kind of stupid, yeah. Really? You should, if we get the card reader one day, did you do it? Yeah, you can probably do it like that. He might be able to with the hat right there, gray shirt, behind the guy in the green, right here, the second row. Yeah, right there. Ask him, he might be able to break that for you and do it.